Hi everyone, I am Joan Lombardi from Intel, and I have the pleasure to present with Bruno Faccini from Intel as well and Kevin Arms from Argonne on the DAOS Lustre integration. So this presentation is really divided into three sections. I will first give a quick overview of DAOS and an update on where we are on the DAOS Lustre integration that was first introduced back at the LAD 2012. Then we will have a short demonstration from Bruno. And finally, Kevin Arms will give us some insight about use cases of this unified namespace at Argonne. So first of all, a few words on DAOS. DAOS is a next-gen object store that is really built from the ground up for persistent memory and NVMe SSD. It uses a traditional client-server model where the server is effectively called an engine. It runs fully in user space. It stores metadata on persistent memory, and data, small data can still store on persistent memory, but data 4K and above will be stored on NVMe SSD. It provides super high IOPS, high bandwidth, and low latency I/O to compute node that run the libDAOS library, which is similarly to RADOS for Ceph, the interface to store data on all those distributed engine. And libDAOS is again a library and has been integrated with different middleware, right? We support traditional POSIX files and directory through POSIX.io. We have integrated this library directly with HDF5. We have our own MPIO driver, our own HDFS connector for Apache, the various Apache framework. We have direct integration with Python through Python dictionary and NumPy. And we've also been working with different very domain-specific data model like Segwile for oil and gas, FDB for weather forecast, Root for particle physics, to really provide more value directly to the application through a direct integration with our low-level object model. So what is important to note here is that it's really a hand-to-hand user space model, right? Even on the client side, libDAOS is a library and everything runs in user space. And DAOS has this notion of container, not to be confused with Linux container. So the unit of management is really the dataset that are called DAOS container. You can see that as a bucket as well, if you are more familiar with S3. And this is really all data generated by a specific application. One application can use multiple datasets if it have some inherent different type of data to store. But the idea is that you will have only a few datasets for each application. And the dataset is the new unit of management. You won't necessarily manage tiny file into this dataset. You will manage the whole dataset as a whole, right? So that's important to understand for the next slide. So this is really the targeted storage architecture that we are shooting for. So you have compute node with a Lustre tier that can be directly accessed by the compute node through the Lustre protocol. And you have this new DAOS tier that was added that is accessed through the DAOS protocol. We already have a parallel data mover based on MPI file utils that can do dataset migration, right? It can move files and directories and subtree from a Lustre to DAOS and ingest that into a new POSIX container, and also migrate data back from DAOS to Lustre. And naturally, it works not just with Lustre, but any POSIX file system. So if you do nothing on the client side, you will really have two different mount points, right? You'll have the traditional Lustre tree, access to the Lustre protocol when you have your files and libraries. And we will also have a mount point for DAOS where you will store all your tree structure and then have special files that point at external container. So DAOS can operate as a standalone solution. You can just use one POSIX container at the beginning that you set up as your root container. And inside this container, you create your file and subdirectory and so on. And then you can have links to external container, to external datasets, right? Like it's represented here. You have simul.h5, which is a special file inside the DAOS namespace that points at an HDA5 container, result.dn that points at the POSIX container, and simul.out that points at an MPIO container. And inside this DAOS tree, you can navigate, you can do cd mnt DAOS Gemini result.dn, and you will automatically see the content of the container, even if you have moved to a new container effectively. The unified namespace concept aim at merging those two trees. So instead of, if you have already an existing Lustre tree, maybe we can reuse this Lustre tree to represent the container, the DAOS container, inside this Lustre tree. That will avoid creating this root container that we have in DAOS and manage everything into a single place. So really what we are doing is what is to achieve is what is represented on the right side, right? You have MNT Lustre, you will have the traditional directory, Apollo, Gemini, and Lustre files, launch.sh, HDA5, for instance, like scripts, libraries and binaries and so on don't necessarily make sense to store on DAOS that uses more expensive storage. So storing them on Lustre and rotating media might make more sense. But then you will have some special files inside Lustre that will be simul.h5, result.dn, and simul.out that will point at the DAOS container in a very similar way as if you were under MNT DAOS. So from a user standpoint, this is really aiming at simplifying things by having a single tree where you can have all your traditional binaries and files stored on Lustre and having sitting next to your DAOS container and being able to manage them under a single directory. So what is interesting is that, so for instance, if you want to launch an HDA5 application, you will give it the path MNT Lustre Apollo simul.h5, and then the special DAOS vol plugin is able to understand that this is pointing at the DAOS container, so it will use the DAOS vol plugin to access it, right, and not go through the traditional POSIX vol. But what is also interesting that when you have a POSIX container, like in the case of MPIO or POSIX container here represented in under result.dn and simul.out, it will be interesting to be able to automatically expand the content of the container so that when the user does cd mnt lustre gemini result.dn and ls, it can automatically see the content even if it is in DAOS at that point, right? So what is represented here on the left side into the shell script is really the view that we want to provide to the end user. To achieve that, so we have made some changes to Lustre that I will detail in the next slide. But under the hood, we still really have two mount points. We slightly change. We have different options when you mount DAOS, and you mount DAOS in a mode where you don't use this subtree, and you have a strict tree that is DAOS, the pool identifier, container identifier. It's a flavor of when you mount DAOS. And effectively, what we have done is that we have represented those containers with special files in Lustre that have a special LOV or LMVEA that store effectively the pool and container identifier, right? This is what we call the foreign layout in Lustre. And then we have changed the client to be able to automatically redirect what you have into this LOV LMVEA to a path, and we are using symlinks for that, right? So this way, when you do cd mnt lustre gemini result.dn, through the symlink, you will be automatically redirected to the diffuse mount point under mnt DAOS cont2, and then when you do ls, you will transparently see the content of your container as if it was directly under the Lustre tree. We have explored different options here before getting to symlink. Obviously, we're going to auto mount and bind mount so that we can make it without changing Lustre. But each time there was several issues with that. One of the major issues is that bind mount and auto mount will really pollute the output of df /proc mount because you can have many containers, right? So and you might hit some limit there as well. So in terms of Lustre changes, we first integrated this foreign LOV LMVEA that allow us to store information that are not Lustre specific, but are specific to an external tier inside the LOV LMVEA. So we needed to do some change to own this format, to change the liblustre API and associated IOCTL, also change the tool, and also make sure that anything that can hit this specific format will support it and will not misbehave. So that's the case, for instance, of LFSCK. Those changes were contributed a while ago and integrated pretty early, so they are available in 2.13. They are mostly server-side changes. And client, obviously, for the tools. The ability to automatically expand a POSIX container under the tree has been provided as a separate set of patches and to convert them as symlinks, and they have been merged into Lustre master now, and they will be available into 2.15. And they are client-only changes. So if you have a server already supporting 2.13, normally you have all the patches that are required, and only the client will need to be patched or migrated to the newer version. Let's now move on to the demo time from Bruno.
Hello, my name is Bruno Faccini and I'm part of the DAOS developers team at Intel. I will demo you the basic behavior and commands of the Lustre DAOS unified namespace. First of all, let's have a look to the Lustre configuration and presets that we will use for the demo. So there is a Lustre file system mounted as a client on the node Wolf151, and the mount point is MNT Lustre. On this file system, I have already created a directory for my user, and it's called Gemini to be consistent with the naming that Johan has been using during his previous presentation. There are specific parameters for the client LLI layer. The first one is enable, and it's intended to enable the DAOS UNS feature support on each Lustre client mount. Second one is a prefix. So the prefix will be used as a pass prefix to direct to the DAOS data, and I will show its effects later during the demo. The upcall one is a userland helper to allow for specific parsing of the foreign LOV and LMV extended attributes format, and mainly to retrieve the DAOS pool and container reference. The fourth one is read-only and is internally used by the helper. Now let's have a look to the DAOS configuration and preset that we will use for the demo. So the DAOS service has also been installed on the same node, and DAOS service is made of several processes. There is also another part, which is the diffuse daemon, and the diffuse daemon is a fuse daemon to act as the door between Lustre and DAOS worlds, and it will forward all operations to DAOS. Now let's create a DAOS pool to act as the equivalent of Gemini top directory on DAOS side. So as we can see, a new UID has also been attributed to the pool. Now in this pool we will create a POSIX container with label result.dn and to be visible as result.dn foreign directory under Gemini. So let's have a look to what we have created on Lustre side. The new foreign directory looks like a symbolic link, and pointing under diffuse with the destination pointing under diffuse mount point. This is confirmed by stat command. When the corresponding container on DAOS side will look like, okay, can use the label to address the pool. Okay, so and if you look at the symbolic link destination, you can see that it's made of the configured prefix. And also it's made with the pool UID and the container UID. So now we can have access to DAOS space directly from Lustre. We can create or copy files in DAOS space. Okay, so last about this, to keep coherency between Lustre and DAOS and prevent orphan containers, the foreign file or directory removal is not allowed. Okay, to be able to remove this, the DAOS can destroy command must be used. So to destroy both the container and the foreign directory. Okay. Let's verify that everything has been removed. Okay, no more containers. And nothing under Gemini now. Okay, that's it. Thank you very much.
Hello, everyone. My name is Kevin Harms. I'm a performance engineering team lead at the Argonne Leadership Computing Facility. Thanks, Bruno, for the demo. I'm here to give an overview of how we plan to use the unified namespace feature on our new Aurora platform. This is just a high-level overview of how we see Aurora from the storage perspective, and I'll kind of walk through this diagram. So first, all these gray boxes represent our compute resources, so the compute nodes or compute racks. The red boxes here represent DAOS, and these yellow boxes represent gateway nodes. And this is how data moves in and off this system. And you can see this blue rectangle that covers all of these things is the high-speed interconnect. So one of the takeaways from this diagram is you can see that DAOS is connected directly to the high-speed interconnect, and as this kind of configuration is sometimes referred to as a platform storage. Next, you can see in these dark purple boxes, this is our Lustre system, and it's external to Aurora and it connects through these gateway nodes. The Lustre storage system is on an InfiniBand storage network. So Lustre, we have two different file systems, and they're both identical. One is called Grand and one is called Eagle. They're each 100 petabytes and have a nominal top-end performance of 650 gigabytes a second. The only difference between these file systems is Eagle has some additional features in Globus where you can share your project data with other members using Globus credentials who may not have access to Aurora directly. But otherwise, all the hardware and Lustre aspects are identical. Looking at DAOS, we see that it has a similar total capacity of 220 petabytes, but its performance is significantly higher at 25 terabytes a second. And so we'll talk more about this design overview when we get there. So I first want to talk about the goals that we had for when we laid out the storage architecture from a user perspective. So ALCF has a wide variety of users. Some of them are experts in HPC systems and system software. Others are experts in some kind of scientific domain and not necessarily experts in using a HPC system. And so we wanted things to be as simple as possible for users to get started. And so we wanted the system to look like they would see other HPC clusters. And so when you get on the system, data access starts with Lustre. Hopefully something that is familiar with many of our users. And then as Bruno demoed earlier, you can create a DAOS POSIX container using a single command and then access that container seamlessly through the Lustre path. This being seamless can be both good and bad, but it enables users to start using DAOS even though they might not fully understand our storage architecture. Next, as far as getting users to adopt DAOS, we wanted to make sure that they could go at their own pace. And so making things easy was critical to that. But we also wanted to have a reason for them to use DAOS. And so you can see in our design, it's intentional that we have 20 times more performance on DAOS as we do on Lustre. This will get users who have high I/O demands to want to use DAOS because it has significantly higher overall performance. And this overall concept will allow users to sort of move their workloads, become more DAOS-centric as they need those features. And Lustre will still serve as our center-wide storage system, so it provides data exchange with other systems, both internally within the center and externally. So currently, Grand and Eagle are connected to our Theta, our Cray XC40. We have a visualization and data analysis cluster, and our upcoming platform called Polaris to be deployed in 2022. All of these systems will use Grand and Eagle currently, as well as Aurora when it arrives. So this having a Lustre system gives us a wide variety of new and legacy systems for users to work with. So how is kind of the user view of how do we set things up? So users, when they have a project, they get a storage allocation as part of their overall compute allocation and other elements of using the system. So projects will receive a Lustre allocation on one of the two Lustre file systems, and they'll also receive a DAOS allocation. They'll be able to use both of these allocations, and both of them are sized so that data can be maintained there for the duration of the project. And so here I've listed, to give you an idea of what the duration of projects are, we have a few different allocation programs. The specifics of these is not so important, but you can see larger programs can store data between 1 and 3 years. And so we wanted to have plenty of capacity in both that users can store data. And our expectation is that DAOS will be used for our high performance I/O, and Lustre will be used for data staging, your code and binaries, backup of data from DAOS, or just cold storage where like you might not be using some data from your simulations anymore, and you want to make space free available in DAOS. You can transfer it to Lustre and then remove it from DAOS, and then eventually to tape backup if that's desired. So then how do users see this functionality when they log onto the system? So when you log on, you'll just see your Lustre file system as you would expect, your home or your project. You can CD into your project space. All your files and data can be shared with your project team as normal. Then you can, using the DAOS commands, create a POSIX container, and that'll be linked into the Lustre file system. When users access that POSIX container, they can CD into it as they would a regular directory, and using the foreign file feature, they'll symlink to the DAOS mount point, and the defuse will mount the pooling container for them, and then they'll be able to seamlessly access any files within that container. So the initial startup, users can easily get started using DAOS with minimal knowledge of how our overall storage architecture is. Then when a user wants to submit a batch job on the compute node, it's the same process as a login node. And in your application binary, if you open a file that's in the Lustre path, the application will access DAOS seamlessly at the file data, or access the file data from within the DAOS container, either using defuse or the DAOS interception library. And this will allow our users to use DAOS, but be able to use a normal POSIX Lustre file system and be able to understand the namespace. I'd like to thank the DOE Office of Science for sponsoring the Argonne Leadership Computing Facility and this work. And then finally, on behalf of Johan and Bruno, I'd like to say thank you for attending.